Right, hello, we're going to be looking at force diagrams and free body diagrams. Now, these are very important in physics because it helps us as the markers to understand what you are going through in understanding this question or any questions to follow, as well as to assist you in understanding what is going on as well. There are two different diagrams that we deal with. We can ask you any in a test, but generally we like to look at our free body diagrams. The force diagrams would generally come with the questions, but we can ask either one in a test. So let's look at the first one. Jason pushes a heavy box along the floor at a constant speed. And remember what we know about constant speed. When we have a constant speed, we know that the F net is equal to 0, right? Because acceleration is 0, ma is going to equal to 0, so F net is equal to 0. So let's look at this one over here. Now, here is the box. Here is Jason busy pushing the box. Yes, I know my diagram looks very, very good. Thank you very much. Right, so I've got this box over here. You can see my normal force is going up. Why? Because it is perpendicular to my surface, right? Perpendicular to my surface. My frictional force is going in the opposite direction of the way that it is being applied or pushed. Then you can see the box is moving this way, so frictional force is trying to keep it going from that direction. And my force of gravity is still coming down. Now, this is the issue that we're going to have. The force of Jason and frictional force, normal force and gravity. Yes, Jason is pushing this box, but where is he getting his power from? He's getting his power from his feet, from his shoes over there. Why? Because his feet are on the floor, pushing in this direction in order to go this direction. So what I want you to imagine is if I am in space, right? I'm an empty vacuum of space over here, and I am just standing in space and I can go nowhere. But what do I want to do? I want to come to my rocket, which is over here on my right. But how do I get to my rocket? What will I need to do? I will need to do, since there are no forces, there's no gravity or anything over here, I will need to do a Kamehameha. Let's see. I will have to do a Kamehameha over here to push me going in this direction. So there's force coming out of my hands this direction, and what's slowly happening is I am moving in this direction over here towards my rocket ship over here, because I'm applying a force in this direction, right? Because there's no other way. So all I'm going to do is, if this is once again me, right, I want to go towards my pen, I'm going to shoot this direction in order to fly this direction over here. So I'm applying a force to my left, but I'm actually moving to my right because there is no frictional force keeping me from going there. So think of these shoes over here, the same thing. When you are walking, you are pushing in this direction in order to walk that direction. Your feet has to do this. It touches the ground and it pushes. Can you see it? I'm pushing this way in order to go. I'm pushing this way, pushing in this direction in order to go this direction. So that is why it looks like that. So when I ask you to draw a free body diagram, you can see this one over here is a free body diagram, but for my Jason over there, yeah, for my Jason over there. You can see Jason going there, frictional force, normal and gravitational. And the opposite is going to be my force of my box going this way, frictional going there, and those two still going in the same direction. Right, thank you very much. Move, oh wait, sorry, still got one more. We're looking at one on an incline now. Right, so we're going to be looking at this on an incline. Right, now, this is very important because we need this to assist us when we are looking at objects on an incline. Just getting everything in order. Right, so we can see I've got this car over here that is on an incline. Once again, excellent drawing skills. So I've got this car. You can see frictional force is going this way. Why? Because my tires are what is in contact with the surface. My tires are gripping on and pushing it this direction for the car to move that way. It's rolling forward. As it rolls forward, it grabs the ground and pushes it that way, which makes the car go forward. Gravitational is going down, and at a 90 degrees perpendicular, we can see our Fn. I've drawn this over here to also show you which direction is positive. I'm taking forward as positive as well as up as positive. That's very important when you're dealing with this. But now that we are looking at an incline, it's important that now we need to look at things perpendicular as well as parallel to the surface over here. So you can see, because I have a 5 degrees incline. So what do? I take this part over here, my contact. You can see I've drawn a little dotted line, but I do the same thing over here. I have dotted lines going down and to the right. Can you see? If I have to take, let's go with this over here. If I have to take this here, you can see there's my angle. And if I apply my angle, it is the same as that over there, which is my FGX. My FGX. Then going at my Fn, which is perpendicular to my ground, you can see, there you go, it is also perpendicular over there, which creates a 90 degrees. And what do we know about these 90 degrees? It allows us to use our trigonometry rules over here, our trig rules. So I've got an FGX and an FGY, and here's my 5 degrees. Right, so looking at that over there, using my cos SOHCAHTOA, SOHCA adjacent over hypotenuse. So you can see my adjacent is going to be FGY, which is this one over here, and my hypotenuse is going to be FG, adjacent over hypotenuse. So it's FGY over FG, but I'm looking for my value of FGY. So what do? I multiply by FG on both sides. That cancels out. So it's FG cos 5 is equal to FGY. So now I've got this FGY. What does this FGY tell me? That it is perpendicular to the surface. So when I'm looking for my perpendicular value, I will use FGY over here. And the same thing if I'm looking for this one over here, which is my parallel value, FGX. Remember, SOHCAHTOA, right? And I'm using my sign over here. So opposite over adjacent. Opposite over hypotenuse. There you go. These two over here. Same thing. Now I've got FGX equals FG sine 5. Now we can see I've got my value for my parallel is this one here. Parallel. Why is it parallel? You can see parallel, same angle. And then my perpendicular, same angle, FGY. Right. And here is a formula over here to assist us in creating all of this over here. Ooh, there's a lot. Okay. So friction minus Fg sine 5 is equal to 0 over here, right? Then I'm going to say, but I know that friction is equal to coefficient Fn. We know that it is coefficient Fn because of the last video that you saw when we're looking at static friction. So therefore, wherever my F was, which is over there, I've taken my this one over the equal sign. So I've got friction, which is this, which is equal to all of that. And that is going to be equation number 1. Equation number 2 is the same thing. Fn minus Fg cos 5 is equal to 0. I take that over the equal sign and I've got this over here. Now, why am I doing this? Because I'm trying to find the value of my coefficients. Right, so if they ever ask you to find the value of your coefficients over here. Right. I'm going to divide equation 1 by equation 2. So there you go. This is all my left sides. You can see my left sides over here and my right sides all over here. Because I've got this, we notice that this Fn can cancel with this Fn. Oh, wait, I've done that. And this Fg can cancel without this Fg. So I've got coefficients sine 5 over cos 5. But we know sine over cos is the same as tas. So you can either say coefficient sine 5 cos 5, or you can say tan 5 over there. And that is going to give you the value of this over here. But please remember, when we're doing this, we're actually trying to find a value. So we would actually input a FG value or an FN value, or both. Right, because we need these values to actually get this. But this is just to show you generally how everything is going to work. Right, this does come out in a later stage. Thank you very much.